Lightstep's observability platform is the easiest way for developers and SREs to monitor health and respond to changes in cloud-native applications. Visit lightstep.com for a free trial.
In the most recent InfoQ Trends Report on architecture, the InfoQ team added designing for sustainability for the first time, suggesting that it's emerging because people are realizing that the software industry is responsible for a level of carbon usage comparable to that of the aviation industry. The question then is, what can we do as individual developers and architects, if anything, and what role does the broader shift to the cloud have? And that's the subject of the podcast today. I'm Charles Humble, one of the co-hosts of the show and editor-in-chief at cloud-native consultancy firm Container Solutions. Before we get into the podcast itself, I just have time to let you know that our online software development conference, QCon Plus, is back this November the 1st to 12th. You can expect curated learnings on topics that matter right now in software development. QCon Plus is a practical conference laser-focused on learning from the successes and failures of domain experts at early adopter companies. If you enjoy the conversations we have on this podcast, you'll get a lot out of QCon Plus. And to learn more about the conference, head to qcon.plus. This week on the podcast, I'm joined by Asim Hussain. Asim is currently the Green Cloud Advocacy Lead at Microsoft and is the chairperson of the Green Software Foundation. He's created a number of courses on JavaScript and related technologies and is the author of a couple of books, one on machine learning with TensorFlow.js and the other on Angular. Asim, welcome to the InfoQ podcast.
Thank you, Charles. Thank you very much for having me here today.
So tell me about your role at Microsoft. What does a Green Cloud Advocacy Lead actually do?
I think we should put the comma in the right location. So it's green, cloud advocacy rather than green cloud, advocacy, which has caused some confusion in the past. Some people thought we had an actual service called Green Cloud, and they were trying to search for it in the Azure categories and they couldn't find it. Like, where's your Green Cloud service? So no, it's essentially looking at, well, really at the end of the day, software through the lens of sustainability. So advocacy in Microsoft is all about connecting with developer communities all over the world. We've got teams inside the organization that focus on different technologies. Or there's a machine learning cloud advocacy team. We've got a reorg right now. So there's a JavaScript cloud advocacy team. There's kind of various people. And really the intention is just to be a conduit between that entire community and the cloud services in Microsoft, both educating, teaching, and training that community about how they can do their work better on the Microsoft cloud, but also listening and saying, well, what do you need? Okay, let's feed that into the product service and make the service more for you. So in terms of Green Cloud advocacy, it's advocating to and behalf of the very fast growing community of, we don't even really have a great name for them, but green software practitioners, people who are technologists who care passionately about sustainability and who think about these questions about, well, how do I do my job? How to do the thing that I spend 8 hours a day or 20 hours a day doing, how to do that more sustainably. And that's both trying to help them understand how do you actually build applications or architect applications in the cloud to be more sustainable. But it's also listening. As somebody who's trying to do that, what do you need? What features do you need in the platform? What are you asking for? How can we feed that back? How can we represent you? That's what the cloud advocacy division in Microsoft, that's what we focus in on.
So accepting your point about the placement of the comma in your own job title there, what is Green Cloud? I mean, the energy that powers public cloud providers isn't 100% renewable, and depending on which region you're in, it might be not renewable at all. It might be 100% from coal or other sort of dirty energy sources. Carbon is being created, right? So what do we mean when we talk about Green Cloud?
I would say it's not a point that you reach. A cloud does not become green. I think it's a direction that you head in constantly. So it's how do you build applications in the cloud, and also, platform providers itself like Microsoft, how do they build services that emit the least carbon possible per unit of work? And that's really what it's all about. And when we talk about green, actually, in terms of green software engineering, that's what we talk about, which is in terms of optimizing for carbon emissions. Putting my Microsoft hat on again. At Microsoft, when they talk about green and sustainability, they have 4 pillars. One is carbon, meeting carbon reduction goals, but also another one, and this is one that the data center team, and especially from a tech perspective, is quite important, is water. Data centers are huge consumers of water, potable drinking water. And how do we make sure that the impact of data centers on the planet, we're still kind of giving human beings, people kind of good access to water, essentially. The other two aspects for Microsoft are waste as well. Another aspect for Microsoft looks at from a kind of greening up its cloud perspective is zero to landfill is the specific terminology. So zero to landfill by 2030. And there's various things that Microsoft's doing from that perspective. We call them the circularity centers. So basically inside data centers themselves, they're opening up essentially places where when a server breaks down, instead of that server going somewhere else, it gets broken down on site. And then those parts are then reused. And the intention is that nothing from that server goes to waste. It gets reused or recycled or something along those lines. And the final one that Microsoft has doesn't particularly relate to the work that we do, but it's protecting biodiversity. And then when you look at other programs, they're completely separate to the work that I do, but other programs on Microsoft, like the AI for Earth program, which is how can you use technology to protect the biodiversity of the planet? And a lot of that's to do with like AI. So those are kind of the 4 pillars of Microsoft when it comes to sustainability. But generally, when we're talking about the work that I do, it's really about how do we build and architect applications so they emit the least carbon possible to our atmosphere. And the main sources of carbon from a cloud perspective are what we call the embodied emissions. So these are the emissions from not just the servers, but all the hardware aspects of computing. All of that emitted carbon when it was created. All of it will emit carbon when it's been destroyed. So that's one of the major sources of carbon. Another major source of carbon is electricity. Most electricity is still created through the burning of fossil fuels. So, how do we be more efficient in how we consume electricity? So there's a lot of stuff that happens in the cloud space around that. PUE, power utilization effectiveness. I keep on forgetting what the actual PUE terminology is. I probably say it wrong every single time. But that's the measure of how efficient a data center is. And energy incoming to energy that actually getting to the servers. And the other one is we are going to consume electricity. So can we consume the electricity in the most intelligent way possible with positive beneficial effects on the energy system so that we all transition to a lower carbon energy future? So there's kind of a whole bunch of different things there, but that's broadly what a green cloud is.
So you mentioned Microsoft's 4 pillars of sustainability: carbon footprint, ecosystem, waste and water. And Microsoft has also published 8 principles for sustainable software. These are things like demand shaping, energy proportionality, carbon intensity and so on. I'll link to them in the show notes actually because I reread them when I was preparing this podcast and they are really good still. But can you talk about them, what they are and the philosophy behind them?
Yeah, so the reason we created the principles a couple of years ago is because we started to say, look, we want to talk about green cloud advocacy and green software engineering. And not everybody agreed on what green meant. So that was kind of the first step is let's get on the same page. And then we realized a lot of the things that you need to know in order to talk about this space are things you're just not taught in a traditional computing environment or traditional education system here. So it was an intention just to level set the conversation. You can gather this stuff if you're doing your own research. It takes like 6 months, a year. You pick it all up. Can we just condense it all into like a quick half an hour training? If you want to have a meeting with a bunch of people around sustainable software engineering or green software engineering topics, everybody just read this or watch this because it's now a series of videos. Watch this. It takes half an hour. Everyone's level set. The language you're using is the same. We know what we're talking about. And so the first principle is all about carbon because the United Nations, what is it, 17 Sustainable Development Goals? And there are some people out there that say that when you're talking about the space, you need to optimize for all 17. It's incredibly hard to get people to optimize for 17. It's incredibly hard to get engineers to optimize for one variable. And that's the variable going for it. It's all about carbon. Whatever you're doing, if the choice that you're making reduces carbon emissions, that's the right direction you should be going in. So we just point you in the right direction. The second principle is all about electricity. It was a surprise for me when I first going into this space. I had no idea, no understanding about electricity. To understand what a major source of the carbon emissions it is in the world right now was a real shocker for me. But it also is a huge opportunity because, as somebody in this space, we know the stuff we create consumes electricity, which means that you can have an impact because if you can use less electricity. The third one was carbon intensity, which you touched on there as well, which is, I think, it's a really interesting topic because you have to understand how the electricity system works. But essentially, there is a measure of how clean or dirty your electricity is. It's called carbon intensity. It's a grams of carbon that is emitted into atmosphere per kilowatt hour, and it varies. And that's what's interesting. It varies by region. because different regions have different things that create electricity. Some things burn a lot of coal to create it. Some things spin really fast when it's windy to create it. And so that means the electricity in different regions is cleaner or dirtier. But it also very interestingly varies over time as well. One of the things about the classic electricity system, the way it's premised historically, has been the battery for our electricity system. We didn't need batteries because our battery was coal. We had this existing chemical battery. And so we didn't need to build any storage because if someone needed more electricity, we just burnt more coal. And now we have a situation where a lot of energy is coming from cleaner sources like renewables, like wind and solar, which means it's variable, it changes over time, and there's no battery. And so if you needed to use more electricity in the past, you just burnt more coal. Now we have these scenarios where how clean or dirty electricity is just varying over time. And so what you as a consumer of electricity can do something called load shifting, which is moving your workload either to a different region where electricity is cleaner or to a different time when the electricity is cleaner. And that is one really interesting mechanism of reducing the carbon emissions of your software. There's others. I don't know if you want to go through all 8 of them, but those are the 3 key ones.
I think that's fine. As you said, you've hit the sort of 3 main ones. But I do want to talk a little bit more about embedded carbon. This is a subject that Anne Curry's written about recently. She was a guest on the podcast, and I know that you know her because she's also on the Green Software Foundation along with you. And she argued in a blog post recently that we should all be architecting our software in a way that means that the hardware will last longer. And I've been thinking about this a bit because when I sort of got started in the industry, in the sort of 8-bit Commodore 64, ZX Spectrum kind of era, the hardware had a relatively long lifespan, and programmers of various kinds learned how to get the maximum out of it. You see a bit the same with consoles now, that they have a relatively long lifespan. While as, say, your smartphone probably doesn't. You maybe keep it 2 or 3 years. There's a similar problem with servers and data centers. And the embedded carbon, that is the carbon used to construct a piece of hardware, is typically higher than the carbon that will be emitted through electricity consumption during its lifetime. So isn't focusing on the software kind of focusing on the wrong thing?
My world is all about trying to answer the question, if you're in the business of building software, what influence do you have? And so, yes, there are other truths out there. Like, yes, a lot of the carbon emissions are with hardware. The solutions, if you're in the software industry, you probably don't have much influence over it. The one thing you do have influence over is, as you said and mentioned, which is kind of, can you make hardware last longer? Which is also just a really challenging request to teams, because your other pressure that you have, just to be blunt, the other pressure that you have is you got to beat out your competition and have the better service that has the better features, that's faster, that, your competitors are doing that as well. But at the end of the day, the only reason, and I think the argument comes very much from a mobile and laptop perspective. Well, mobile and kind of tablets are very much the types of devices where they're so energy efficient these days that most of the carbon is in the embodied carbon from that. Servers are different. Most of the carbon will be from the electricity that servers consume, just because they're powerhouses. Your mobiles and your laptops and your tablets are they're just built a little differently. The screen goes off. They're actually built in such a way that it reduces the clock cycles if it's not being used. It really conserves it a lot. And it's not going to break. There's no moving parts. It's not going to break. So I'm going to make a decision to get rid of this mobile phone. That's all that's going to happen. I'm going to make a decision to get rid of it. And that decision will be influenced by my perceived performance. So applications I'm using on it might start feeling a lot slower. That's because applications are just now coded up to expect, the latest chipsets. And it's also perhaps vendors are going to just stop building applications that work on my phone. I remember when I had to get rid of my mum's phone a while ago because Skype just stopped working on it. There was nothing we could do. We used Skype, so we just had to get her a new phone. That was the reason for it. It was just an application stopped working on it. And so from a software perspective, we had it a long time anyway with the feature phones movement, which is if you wanted to encompass the global audience out there, you had to stop writing your mobile applications for the 1% of people that owned an iPhone 13. And you needed to start looking at the breadth of people. A vast majority of the world do not have the kind of powerhouse devices that the bleeding edge has. So you do need to start looking at them and building your applications that way. You can look at the web world, which does a lot of stuff around kind of progressive enhancement. So rather than right now assuming that someone's got the latest spec and kind of like trying to degrade it somehow if they've got a lower end spec in the web world, the right method is assume someone's got, well, it's not based on specifications, but, other features. Assume people are at the lower level and only build in additional functionality if you've detected that they actually have those features available. Those are some of the ways you could actually start building software to work on older devices.
What are some of the other things we can do? We've talked about demand shifting, so moving your workloads around to take advantage of more green sources of energy. But what else can we be doing as developers and as software architects now?
So I think it still factors into it when we look at carbon awareness, because there's actually two aspects of it, which is really when you kind of double click into what you're actually doing when you're responding to signals from the energy system. Because that's all that this is. This information, which is carbon intensity of electricity, it's just information from the energy system telling you this is my state that I'm in, respond accordingly. When you run software, when the carbon intensity is less, what you're doing is running software that's coming mostly from renewables, which means you are then supporting those power plants that are renewable power plants. So you're helping to transition the energy grid towards a renewable powered one. The challenge, everyone talks about we need electricity to come from 100% renewable powered sources. That's our goal. That's the goal. The UK grid needs to be 100% powered by renewables. The challenge with that is that we don't have control over when the energy is coming or going.
Right, and related to that is the whole problem of storage and density, energy density. So fossil fuels are, on the whole, very energy dense, and oil is extremely energy dense. Nothing else really compares with it at all. I believe I'm right in saying that solar energy, for example, has a density of about 1.5 microjoules per cubic metre, which is about 20 quadrillion times less than oil. We've backed away from nuclear, which I would argue was probably a mistake, although, there are reasons why. But we're now in this situation where we need to be able to store the energy generated from renewables, and we don't yet have a way to do that, right?
If I had a slide I could show the audience, I could explain it. But one of the really interesting things that happens when you look at what you're doing, when you're shifting electricity, for all intents and purposes, you look like a battery. I know this sounds kind of conceptually, it's weird. How can software look like a battery? But for all intents and purposes, to a utility provider, you're a battery. So the ability to shift loads around at different times is that equivalent. In fact, another term that's often used in this industry is called a virtual power plant. Load shifting through time and through space looks like a power plant because you can say moving workloads at different times acts the same way on the energy system as a power plant. So there's actually startups and stuff that are trying to IoT the world together, all the battery storage devices in the world together, like laptop battery storage devices together and EV charging devices together, because it looks like a power plant. So when you make your application carbon aware, not only are you taking advantage of lower carbon electricity, so you yourself can then argue, well, my application is emitting less carbon, you're actually playing a part in the transition, which is kind of the point I wanted to make. You're playing your part in helping the energy systems move towards a renewable future, which is, I think, an interesting add-on to that whole process.
Right, and what's interesting there is, presumably, if there's some way that you can measure your carbon use, your impact over time, then that becomes another thing that as developers and as architects you can be optimizing for, in the same way that you might optimize over time for financial cost. You might monitor the price of your Amazon bill, and if that suddenly spikes, then you would investigate that and hopefully bring it back down again. You could be doing the same thing for your carbon usage if you could get the data, if you could monitor that. But how do you get the data? How do you monitor what's going on?
So it's one of the things that we're working on in the Green Software Foundation is that it's the measurement process. Like every one of our member organizations have identified this as their biggest challenge is we need a method of measuring our software because the existing methods of measuring have problems. Like right now we have the greenhouse gas protocol. That's the main method people use to measure everything inside organizations. The really annoying thing about software is that it doesn't all fit inside an organization. One example I give is Windows. So Windows is used by however many hundreds of thousands of organizations in the world. But The way the greenhouse gas protocol works is only the Microsoft employees that use Microsoft Windows would factor into scope 1 and 2 at least, which is a part of the emissions characteristic. And open source as well. Like there's no organization around an open source project. And yet everything we use in the cloud, pretty much everything we use in the cloud, is based on open source technologies. How clean and dirty those open source technologies. An organization might have pressure on itself to make its proprietary technology greener. But really, you probably want the open source technologies underneath it to have the similar pressures to become more efficient or to have greener applications. And so the thing that we're developing is something called a software carbon intensity specification, which is not a total, it's an intensity, it's a rate. So for Windows, it might be carbon per user. And also the other position that we've taken is that neutralizations, and by neutralizations we mean offsets, and renewable energy credits, and kind of what we talk about with renewable energy is actually the way it's bought and sold is actually an offset. So we have taken the position that offsets are very important, but they shouldn't be factored into the calculations from a software perspective. Because if you were to give an organization a choice, say, look, you need to reduce your carbon emissions of your software by 50%. It's going to cost you 20 million to do that if you used our dev teams to do it. Oh, and by the way, you probably won't be able to deliver half the features you want to deliver over the next year. Or you can spend 500,000 on buying some offsets. Most of the time, people would purchase offsets. The investment wouldn't flow into the things we need it to flow into, which is reducing the emissions of your software systems. And that's why we're building kind of the SCI from scratch. It's built up 100% for software systems, whether you are a huge distributed cloud system or a small monolithic open source library, it's applicable to you. And the fact that it's a rate rather than a total means it incentivizes reductions rather than neutralizations, which is where unfortunately a lot of the effort tends to get biased towards these days. And that's kind of the big challenge that we have, is to have a method of measurement that is designed just for software.
So what are the next steps for the Green Software Foundation?
A lot of our work right now is focused around the initial release of the SCI specification. Post that, it'll be focused around ensuring people understand how to apply the SCI specification on a whole variety of use cases, from cloud to all these other things. And then the next step is ensuring people have the data, because a lot of this stuff requires data. Calculation stuff requires data. The SCI is quite theoretical without access to the data. It's still useful, but it's kind of theoretical. So the next step is, how do we ensure that that data becomes available? One of the directions we believe is to work with policymakers. The SCI in some shape or form becomes policy somewhere, then we're just going to see the data flow. The data is going to be made available because there'll be a regulatory requirement to make it available. If we can make the SCI somehow included in kind of ESG ratings inside organizations, we call them ESG consultancies that kind of give ESG ratings to organizations, then that will kind of encourage the opening up the data. But really, what software needs, the biggest challenge we need right now is the data. We need to know, we need to be able to measure. Almost the rest of it is quite easy. Once you can measure, understanding what you need to do to reduce is not that complicated. We all know what we need to do to reduce these days. It's use less electricity, fewer hardware resources, and electricity more intelligently. We can write down what all those options are. Without a method of measurement, it's hard for organizations to invest effort into this. And it's hard for organizations to prioritize what project do you do first. Without understanding the impact, how do you know which do you focus on? Energy reduction? Do you focus on hardware reduction? Where do you focus on first? So measuring is what it's all about. So from the SCI, that's the foundation's initial focus. We've also got a large community aspect to it as well. So large community education. It's actually growing the audience of what we call green software practitioners. We will be focusing a lot on kind of speaking and events just to get the message out. And that once they've got the main kind of SCI focus done, we'll be starting to run workshops. Everything we create is open source and Creative Commons. We're creating Creative Commons workshops that anybody can run inside their organizations to teach them how to take any type of cloud application or whatever and make it greener. And then we're growing a global network of meetups and really trying to expand the set of people out there. If you're an organization, it's very, very hard to find somebody these days who's knowledgeable enough to advise you concretely on how to reduce the carbon emissions of your software system. So our goal is to increase that, or increase the set of people that the organizations can reach out to and hire with the set of knowledge to be able to do this stuff.
So finally, if listeners want to get involved in the Green Software Foundation, how can they do that at the moment?
Well, if you are an employee from one of our existing member organizations, which is quite likely because the number of employees, I think I calculated, there's about 1 million employees of our member organizations, their parent companies, is to reach out to your representatives. You go to the greensoftware.foundation website, reach out to them, and they'll tell you how to get involved. If you're interested in joining the Green Software Foundation, again, head to the website. We have various levels of membership from like steering to general. We don't right now have kind of like what we call a contributor membership, which means that if you're not joining as part of an organization, unfortunately, it's really hard for you to join the foundation right now. But join our newsletter because a lot of what we do is out in the open. It's open source. Just the same way you can get involved with any open source project, you'll be able to get involved with any kind of foundation project that is open source. It's just that members get access to our Slack, and the act of joining the foundation is acknowledging you agreed to a certain set of rules regarding patent, IP, and copyright. So that usually happens in the more private forums. If it's all out in the open source, it's fairly straightforward. But if you want to join kind of the private forums and take part in the voting and things like that, you've got to be a member, if that makes sense. But yeah, generally head to the website. Right now, the best thing is to join our newsletter and we'll let you know the stuff that we're doing.
Great. And listeners can check the show notes for this episode, and I'll make sure there's a link to the Green Software Foundation website in those. Asim, thank you very much indeed for taking the time to talk to us today on the InfoQ podcast.
Thank you, Charles.